This is the chapter of soil. This is the chapter of soil classification. So we're going to start with the introduction with the next slide. So as you can see here, we will going to discuss the introduction of soil classification. So if you talk about, if you want to talk about to classify soil in general, it can be classified as a cohesion-less soil and cohesive soil, right? All we know that cohesion-less soil is falling under the category of coarse-grained soil, and cohesive soil is falling under the category of fine-grained soil, right? So simply, soil can be classified as a cohesion-less soil, as a coarse-grained soil, and cohesive soil as a fine-grained soil. But these terms are very, it's too general, and one has to include the wide range of properties for the classification, for the for the engineering purpose. That's why additional means of categorization is required to use a soil in the engineering practice, and for that the term soil classification has been introduced, right? So if you want to classify the soil, right, so simply we can say that soil classification is simply arrangement of soil into different categories in such a way that the soil which is falling under the particular group will be having a particular behavior. For example, a soil which is falling under the same group will be having similar behavior, and and putting the soil into different group is itself is what arrangement of soil into different group. That is itself is soil classification, right? All we know that soil are of wide varieties, and its properties are different, and its behavior is different. So there's large variation in its properties as well as in its behavior, right? That, like, this is a reason why we need to. So if we talk about the purpose of classification of soil, is from engineering point of view, it is to select a soil as a foundation material, also to find suitability of soil, right? So this is what function of, or sorry, the purpose of the soil classification. So if you talk about the soil classification, no, index properties of the soil are mostly used to classify to classify the any of the soil. Also, in some case, grain size distribution is also used. So simply, if we say index properties, grain size distribution, and plasticity properties of soil will be used to classify the soil. So several classification systems are developed for a different purpose, so that we will going to discuss in the next slide. So as you can see here, the if you talk about the various classification methods, so the very first method is a particle size for particle size distribution or particle size classification. This classification is based on the particle size. Second is structural classification. Next is ESPO classification. Next is unified soil classification and Indian standard classification. These five methods were evolved for different purposes and to be used in different fields. The soil can be classified. So in the next slide, we will going to discuss all these different methods of classification in a detail. So let us go with the very first particle size classification. So as you can see here, so here we're going to discuss the particle size classification, or the classification based on the particle size. So if you see here, the size of individual particles present in the soil mass has importance in behavior of the soil. Say for example, if more number of particles are present with the particle size of particles, then its behavior will be completely different. Similarly, if another size of particles are more present into the soil mass, then its behavior will be different. That's why the size of individual particles are having quite a good influence on the behavior of the soil, right? So in this particle size classification, the soils are arranged according to the grain size, ranging from very finest particle to the coarsest particle or from the coarse particle to the finest particle. So in that arrangement, the soils are arranged, right? So in this method of particle size classification, four broad groups of soils are denoted, that is gravel, sand, silt size and clay size. Here please note down one thing, this is silt size, not silt, clay size, not clay. Okay. So the soils are categorized under four category of gravel, sand, silt size and clay size. Okay, whenever we classify the fine grained soil based on the particle size, no, it is better to use silt size and clay size instead of silt and clay. What is the reason? The reason is mentioned in the in this sentence. The reason is, whatever soil which is said to be clay and silt, no, it is exhibiting the plasticity and cohesion behavior over the change of the water content, right? Whenever we use clay and silt, it will going to exhibit the plasticity and cohesion characteristics with a different range of water content. If we talk about clay size and silt size instead of clay and silt, it means it will not going to exhibit the properties that is associated with the clay and silt. So always in the particle size classification, better to use clay size and silt size instead of clay and silt under the four broad group of soil. So its justification is given here. If you talk about the rock floor, right? The rock floor, the rocks are powdered into the finest particle, so that particles are said to be the size of clay, not as a clay, because the clay particles of rock floor doesn't exhibit the properties of plasticity, right? That's why it is said to be of clay size instead of clay, right? This is the reason why we need to use clay and silt size, right? But if we talk about classification based on particle size, it would be good to it would be good for coarse grained soil, but in case of fine grained soil, it would be somewhat misleading. Why? Because the behavior of fine grained soil is only depending upon the plasticity characteristics, not depending upon the particle size. I'll repeat once. If we classify the soil based on the particle size, it would be good to classify the soil based on particle size for coarse grained soil, not for the fine grained soil, because its meaning will be misleading. Because the behavior of the fine grained soil will be only depending upon the plasticity characteristics of the soil, right? So the classification based on particle size can only be done in case of coarse grained soil, because the behavior of the coarse grained soil is only depending upon the which size of, in how much amount the particles are present. Okay. So as you can see here, this is a particle size classification. See, this is simply different particle size classifications are given as per the different authorities. This is given by the US Bureau. This is international classification. This is MIT classification, and the very last is Indian Standard Soil Classification, right? This is already we have discussed in the chapter of particle size distribution, where the particle size less than 2 microns are said to be clay. The particle size between 2 to 75 micron are said to be silt, and the soil which is less than 75 micron are said to be clay and silt. Okay, the particle ranging from 75 micron to 4.75 mm are said to be sand, and this sand are further classified as a fine sand, medium sand and the coarse sand, right? So fine sand is from 75 micron to 425 micron. From 425 micron to 2 mm it is medium sand. From 2 mm to 4.75 mm it is coarse sand. So this is a classification of coarse soil as a sand as per this particle size. And the particle size of 4.75 mm to 80 mm are said to be gravel, out of which there's a its further bifurcation is fine gravel and coarse gravel. So the fine gravels are those gravels which is having a size between 4.75 mm to 20 mm, and the gravel which is having the size from 20 mm to 80 mm is said to be coarse gravel, right? Similarly, from 80 mm to 300 mm of particle size are said to be cobbles, and above 300 mm size of particles are said to be boulders. So this is what particle size classification as per Indian standard, right? So this is said to be simple particle size classification. So, we will going to discuss the textural classification. See, by hearing the word textural classification, one can get rough idea about the classification is based on the texture of particles present into the soil mass, or the appearance of the particles present into the soil mass, right? So the textural classification is depending upon the size of particle, shape of particle, and gradation of particles. So these three points are factors are very important. There is particle size, shape of particle, gradation of particle, which defines the texture of particles present into the soil mass. So based on this, the textural classification has been like explained. So if you refer the textual classification, then there's a it can be done based on the particle size, right? So it means if you talk about these three factors, particle size can be considered, but it is difficult to consider the shape of particle as well as the gradation of particle. So here, if you see this chart, so only the size of particles are considered for silt, clay, and sand. What is that? We will discuss it later on. So this method of classification has been suggested by the US Bureau of Public Roads, which is simply calling it as a textural classification. So this term texture is depending upon the how much percentage of sand, silt, and clay are present into the soil mass. So depending upon the percentage of sand, percent of silt, and the percentage of clay, the classification of particles as a texture can be done. So as I told you, this method has been evolved by the US Bureau of Public Roads. The particle size will be according to the particle size classification of US, not as per the Indian or not as per the MIT, right? So here, if you talk about the sand percentage, the sand size as per the US Bureau is between like 2 mm to 0.05 mm. Okay, similarly for the silt, it is from 0.05 to 0.005 mm, and for the clay it is less than 5 micron. In Indian standard, what we consider clay size is less than 2 micron, but in the US standard, it is considered less than the 5 micron. So as I told you, this is the texture classification is depending upon the percentage of sand, percentage of silt with this size, percentage of clay with this side can be plotted between the three sides of equilateral triangle. See, if you see this diagram, right, this is equilateral triangle in which this side is representing sand, this side is representing silt, and this side is representing clay. Okay, as you can see here, all these three sides of this triangle are equal, right? So each side is bifurcated into the or divided into the 10 equal zone, right? Or 10 equal lines. As you can see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 division here, 10 division here, and 10 division here, right? So by using the percentage of all these divisions along with these lines, the classification can be done by the zone, like in which zone the soil is falling, and like in whichever zone the soil is falling, according to that soil can be classified. But how to use this chart, right? To use this chart, one key is given here. Please look at here. This is one key to use this chart. As you can see here, this side of triangle is representing silt, this side of triangle is representing sand, this side of triangle is representing clay, right? So here, if you see this silt side of triangle, right? So if you see the silt, so which lines are representing the silt percentage? This line. It means with respect to the horizontal axis, all these lines, please see the arrow, or the cursor, all these lines are representing the silt content, right? Which lines? This line with respect to horizontal axis. Similarly, if you talk about clay, right? So this side of triangle is representing the clay. So as you can see here, what this key is representing, the horizontal line with respect to the side of clay line is representing the clay content. So as you can see here, this is clay line of clay side of triangle. So this is 1, 2, 3. All these horizontal lines are representing content of clay particles. Understood? Similarly, if you talk about sand, so this inclined line are representing the content of sand. So let us see here. So this is side of triangle which represents the sand. So these lines are representing the content of sand. So content of sand as per the percentage, content of clay as per this percentage, content of silt as per the percentage, and bisecting point of all these three lines will be giving an idea about the classification of soil based on the in which zone the soil is lying. Okay, so let us take one example to classify soil by using textural classification. So let us take one soil which contains 30% of sand, 20% of silt, and 50% of clay. Okay, so and we're going to classify the soil by using this percentage, right? So let us see here 30 percentage of sand, right? So as you can see here, this line we're going to use for the to represent the percentage of sand. So 30 percentage of sand, this dash line, right? 20 percentage of silt, so 20 percentage here. We'll have to bisect 3 points, right? So whichever zone is representing bisect by the bisecting point of these three lines is representing the textural classification. So this 20 percentage of silty line, this silt line, not silty, sorry, 30 percentage of sand, this line. Let us see 50 percentage of clay. Now you can see here this 50 percentage of clay is plotting here along with the 20 percentage of silt and 30 percentage of sand. 30 percentage of sand, 20 percentage, this 20 percentage of clay, and this 30 percentage of sand, and this 50 percentage of clay. So as you can see, the bisecting by this 3 point here, so in which zone the soil is falling, the zone this is representing those, this point is showing clay. As you can see, this point will be getting, so as you can see this point, the whole this zone is representing the clay, right? So this particular point is representing which soil? Clay. So you can see here the soil is classified as clay, right? So this system can be used when the soil contains different constituents. Okay, so as you can see here, but this can only be possible for the sand with the maximum size of 2 mm and the clay with the minimum size like less than 5 micron of size. So what if a soil is containing a particle more than 2 mm, right? Because it can be possible now, like the soil might contain the particle size greater than 2 mm. So in which case one has to apply some corrections. How? That we will discuss. So like already we know the percentage of sand, silt in clay must be 100 percentage, but if the percentage of particle size more than 2 mm is present, so this percentage becomes more than that. So let us take an example, and you'll be better understood by one example. So what we are assuming is, out of 100%, 20% of these particles are of greater than 2 mm size. Out of 100% of soil, 20% of the soil is having a greater than 2 mm of size. Now tell me, 20% is greater than 2 mm size. So less than 2 mm size of particles will be having how much percentage? 80 percentage. And less than 2 mm of particle size will be having sand, silt and clay. So can we say that sand, silt and clay particles will be having 80% of the soil? Yes. So let us take one more example. This 80 is further bifurcated as some percentage of sand, some percentage of silt, and some percentage of clay here. So in this soil, 12% of sand, 24% of silt, and 44% of clay is present. So the summation of this 12, 24, and 44 is 80%. So we will going to classify the soil by using this. But all we know that out of this 20% of the soil is of greater than 2 mm na. So one has to apply correction factor. So correction factor will be depending upon how much size of particles are there out of 100 with this particular particles, right? So 80% of particles are of size less than 2 mm, right? So 100% of total particle divided by 80% of the particles are of this size. So whatever correction will be getting from the 100 divided by 80, that value will be multiplied with these three values, right? So whatever correction will be getting here, it will be multiplied with the 12. So correction factor will be getting as a 15% of sand instead of 12, right? By multiplying this correction factor. Again multiply this correction factor with the 24 percentage. Now you will be getting the modified or corrected value of 30% of silt instead of 24. Now again multiply this correction factor with 44 percentage of clay. You'll be getting 55 percentage of clay as a corrected. So instead of 12 as a sand, 24 as a silt, and 44 as a clay, will be getting modified corrected percentage 15 as a sand, 30 as a silt, and 55 as a clay. So now we're going to use this percentage to classify soil as a textural classification when some percentage of particles greater than 2 mm size will be present into the soil mass. Understood? If all the particles of soils are less than 2 mm of the size, you can simply use this percentage or whatever percentage is given. If the soil is containing some percentage of particles more than 2 mm size or greater than 2 mm size, then you will have to use correction factor. You'll have to multiply the correction factor with the actual percentage and you'll be getting the corrected percentage, and the corrected percentage will be used to classify soil as per the textural classification. So this is similar whatever we discussed in the upcoming previous slide, that is represented here similarly. Okay, you can see here the classification can be done. So the detailed usage of ASTO classification chart we will going to discuss in the upcoming slides. But here in this slide we will going to check the suitability of soil as a foundation material for highways for the fine grained soil, right? So if you see this is a one, you'll have to find the group index. So based on the group index one can classify the soil as per the ASTO. So if you see the equation of this group index, this is the initial equation was developed. After that this equation was again modified and written like this. If you see this 0.2 f minus 35, this is one term, right? This is another term with f minus 35 into liquid limit minus 40. Third term f minus 50 into ip minus 10. So this is first term, second term, and third term, right? So this equation has been written in the simplest form here. If you see 0.2 into A. A stands for F minus 35. Now what is F? We will discuss later on, right? So 0.2 A first term, 0.005 A C second term, C F minus 35 A here, F minus 35 percentage again A here, right? WL minus 40 liquid limit minus 40 C term. So the second term over. Third term 0.01 into B into D. So B stands for F minus 15 and D stands for IP minus 10%, right? So this whole equation is written in the simplest form here, right? So if you see here, what is A? A is equals to F minus 35. So I have written here A is equals to F minus 35. Now you must be wondering, what is F minus 35? See, all this F 35, so this is representing some percentage, right? If you see right? A term. What is A? A term is nothing but simple the percentage of the soil which is passing from 75 micron, and that percentage must be greater than 35, and it should not exceed more than 75, right? So again I'll repeat, A is representing that portion of percentage of the soil which is passing from 75 micron, which should be greater than 35 and should be less than 75, right? At 75 and 35 is percentage, right? So this is what percentage. A is representing what? Percentage. So whatever value we'll be getting here in A, it must be within the range of 0 to 40. What you can say, it should not be less than 0, it should not be more than 40. Suppose you are getting the value of A as F minus 35, you'll be getting F minus 35, that is A, equals to 50, and the maximum criteria is given as a 40. So what you will have to use? You will have to use 40 instead of 50, because the maximum limitation of factor A as a percentage is given 40. So whatever value you will be getting, if it is other than 0 to 40, you will have to use in between value. If it is 0, you can take 0. If it is more than 40, you will have to take 40. Understood? Good. And what if the value of A you will be getting as in terms of negative? If you will be getting the value of A in negative, it should be considered equals to 0. Whatever value out of all these four terms will be getting as a negative, it must be considered equals to 0. Understood? Next is B. What B is representing? B is equals to, as you can see here, B is equals to F minus 15. Again, what is F? F is percentage of that soil, right? F, always see, I have written here, F is simply the percentage of soil which is passing from 75 micron, right? So what is B? B is representing that percentage of the soil which is passing from 75 micron, right? And that percentage of the soil that is passing from 75 micron should be greater than 15 percentage, and it should not be more than 55 percentage. So here the B percentage, whatever percentage as a B value you'll be getting, it should be more than 15 and it should be less than 55. Understood? In terms of percentage, like percentage of sand, percentage of clay, percentage of silt, percentage of whatever, right? So whatever percentage you'll be getting as a fines or as a 75, as a less than 75 micron, that percentage should be greater than 15 and less than 55 as a B value, right? As in case of B, and the value of B must be between 0 to 40. Understood? Similarly C. So what does the value of C is representing? C is representing liquid limit minus 40. Liquid limit minus 40. It means it is that portion of liquid limit which is greater than 40 and it should not exceed 60. Okay, so the value of C should be represented in such a way that the liquid limit to use this C as a F minus, this C as a WL minus 40 must be greater than 40 and less than 60. Again, this term should be positive. If you'll be getting this term as a negative, it should be considered equals to 0. Similarly, you can see here the very last D percentage, that is a percentage of plasticity index which is greater than 10 and it should not exceed 30, right? So its maximum value is from 0 to 40. So if you're getting the value of D as a 30, no, you'll have to use the value as a 20 because the maximum value can be 20, right? So this is what the equation by using which you can find the group index for a particular type of soil. Okay, good. Let us discuss the next slide. So if you see this So, as I already explained in the previous slide, the maximum value of this term f minus 35 and f minus 15 must be taken as 40. The value of f minus 35 and f minus 15 cannot be taken as a more than 40. Similarly, the value of liquid limit minus 40 and the plasticity index minus 10 can be taken as a 20, right? So this is the maximum value for these two terms, and this is the maximum value for this and these two terms. F stands for percentage soil passing from 75 micron. WL stands for liquid limit. IP stands for plasticity index, right? So what I said in the previous slide, if the value of any of the term or the value of GI becomes negative, it is dropped and it is the value is taken equals to 0. Now how the GI value or the group index value representing the soil type and commenting over the type of soil over suitability of construction material. So as you can see here, the greater the value of GI, the lesser the soil will be desirable for the construction of highways, right? So what I'm saying, if the it would be good if the value of group index is less for the suitability of soil as a construction material. The smaller the GI, the better is the soil for the construction of road. Okay, so as you can see here, the group index of 0, if we'll be getting the group index of 0 for any of the soil, it is representing soil as a good subgrade material. Why we are using it as a subgrade material? Because already I have told you the SO classification is developed for for the classification of soil that is used for the highway construction as a base and subgrade material. So and if the GI value is more than 20 or greater than 20, it is showing a poor soil as a subgrade material. So the GI value must be mentioned even if it is equals to 0 to indicate that the soil has been classified as per the ASTO classification system. So if you see this chart, see this is not a Vasto chart. This is one of the chart which gives idea about the classification of soil as per the group indexes or as per the broader group of ASTO classification by using plasticity index and liquid limit. Based on the value of this and these two values, one can have idea about the in the zone the soil is lying, and depending upon this A-5 or A-7-5, whatever the zone, by using the ESO classification chart, you'll be having a detailed idea about the type of soil that we're going to see in the next slide. See, this is very important for classification of for the classification of classification of soil as per the ESTO system, right? So if you see this chart over here, general classification of soil is given, right? The classification of soil is given, and this is representing some characteristics or some properties of the soil, right? So as you can see, the general classification can be done for the granular material and for the silt and clay material, silt dash clay material. Okay, or you can say 35% or less than 35% soil is passing from 75 micron, then one can go for granular classification. Or you can say if the percentage of soil, mark my words, if the percentage of soil which is passing from 75 micron is less than or equals to 35%, soil is classified as a granular material as per ESTO classification. Okay. Similarly, if the percentage of soil passing from 75 micron is more than 35 percentages, so it is said to be silt and clay material. So what you need to check very first is, you'll have to check the very first how much percentage of soil is passing from 75 micron. 75 micron you can say, or number 200 ISU you can say. Okay. In ESO class, as you know, the ESO classification has been developed by the US. The US system used numbers of sieve instead of size of sieve. So 200 number of ISU, sorry 200 number of sieve, not IS, 200 number of sieve, or 75 micron IS, 75 micron size of ISU, both are same. So what you need to check is how much percentage of soil is passing from 75 micron. If it is less than 35, soil is granular, greater than 35 soil is silt and clay. So these two criteria you will have to check the very first. Second, if you see this, the as I told you, the soil is classified as a main into the 8 groups. One is A-1, A-3, A-2, 4, 5, 6, 7 and A-8, the very last, which is said to be peak and silt, which is not mentioned over here, right? As you can see, how to use this chart. You must be wondering how this chart can be used. See, to use this chart, one has to understand one thing, that you'll have to check all these criteria ranging from A to D. Mark my word, you'll have to check every criteria from A to C to classify the soil, and you'll have to check starting with the very far very left, the very first column on the left side, right? So say for example, if you have some percentage of soil passing from 2 mm, 425 micron, 75 micron, some liquid limit, some plasticity index, what you need to check, you'll have to check first here whether the criteria is satisfying. No, then move further. Check here the whole criteria, not this one only, this whole criteria, right? Check this criteria. If it is satisfying, then the classification will be based on this. If it is not satisfying, go further to the right side. Again, if this is not satisfying, again go further to the right side. So you'll have to check every column unless and until the criteria of percentage passing 2 mm, 425 micron, 75 micron, percentage passing 425 micron, liquid limit and plasticity index. You will have to keep on moving from left to right side unless and until which group is satisfying the characteristics or criteria which is given to you for the particular type of soil. So this way soil can be classified by using ESTHO classification chart, right? So as you can see here, A-1 has been further bifurcated into these two subgroups, A-1 dash small a, A-1 dash small b, depending upon the value of percentage passing from 425 micron and the percentage passing from the 75 micron, right? So simply, in a simple word, we can conclude about the ESTHO classification system is that to classify the soil as per the ESTHO system, you will have to check very first percentage passing from 75 micron is less than 35. You will have to check this criteria for A-1 to A-2 group. If it is more than 35, you will have to check this to this group for all these particular type of particular types of characteristics, right? So you'll have to check this and all these criteria working from the very first column to the second column, third column, next column, unless and until all these criteria satisfied for a given soil, right? If it is satisfied as A-2-6, soil is classified as a silty or clay gravel sand. If the criteria satisfied for the A-5, soil is said to be silty soil. If the criteria satisfied for the A-7, the soil is said to be clay soil. So this way one can classify the soil as per the ESTHO classification system. You can see this criteria of A-7 is having two subgroups of 1-7-5, 1-7-6 within one group only. So how to check whether the soil is 1-7-5 or 1-7-6? So for that, one note is given here. If the value of plasticity index is equal or less than this difference, mark my word, if the value of plasticity index is less than or equal to this difference of liquid limit minus 30, soil will be said to be A-7-5. Okay, and if the difference of, if the plasticity index is greater than the difference of liquid limit minus 30, so it will be said to be A-7-6. So based on the value of IP, whether it is less than or equals to this difference or greater than equals to this difference, soil can be of A-7-5 or soil can be A-7-6. Okay, so this is the classification of ESTHO. Thank you. We'll now we're going to discuss the next slide or next topic. So before jumping to the next topic, this is a simple, understanding point of view. That so classification is given, right? A1 to A3 say to be granular material, A4 to A7 is said to be silt and clay material. Already we discussed in the previous chart. And if we talk about the, suitability of soil, A-1 materials are said to be well graded. A-3 soils are said to be clean, poorly graded sands. A-4, A-5 soil are said to be silt, and A6, A7 are said to be clays. So A6, A7 soil is clay, A4, 5 is silt, A1 is well graded, and A3 is clean, poorly graded sand. Okay. So which kind of testing will be required for the ASTO classification of ASTO classification? For that, one has to have the idea about percentage of particles present in the soil mass. For that, sieve analysis will be required, and to have idea about the liquid limit plasticity index. For that, Atterbuck's limit will be required. So simply sieve analysis as well as Atterbuck limits will be required for the classification of soil as per the ASTO system.